Pluto had it coming from the beginning. It was never really belong. Pluto's orbit crosses that of another planet. That's no kind of behavior for a planet.
In the frozen outskirts of our solar system, two worlds have been locked in a cosmic dance for billions of years, never touching, never colliding. But now, whispers from the world of astronomy suggest that something may be disturbing that fragile balance. Neil deGrasse Tyson has issued a warning that hints at a chain reaction reaching all the way to Earth. If he's right, what's coming won't just rewrite textbooks. It could change everything we thought we knew about our place in space. Pluto's extreme orbit. When Neil deGrasse Tyson speaks, the scientific community and the public tend to listen, thanks to his decades of solid, respected work in astronomy. Tyson is not just another popular science figure. He's an American astrophysicist, an accomplished author, and one of the most recognizable science communicators alive today, who has had his contributions recognized at the highest levels. He has been the director of the Hayden Planetarium at the American Museum of Natural History in New York since 1996, a role that has placed him at the center of public education on the cosmos for almost 3 decades. His academic background is equally formidable: an undergraduate degree in physics from Harvard University, a master's degree in astronomy from the University of Texas at Austin, and a doctorate degree in astrophysics from Columbia University. Over the years, Tyson has shaped public debates on topics ranging from space exploration policy to science education. Perhaps most famously, he became a central figure in the public's understanding of, and controversy around, Pluto's reclassification from a planet to a dwarf planet in 2006. That debate didn't just redefine a world at the edge of the solar system. It cemented Tyson's role as someone unafraid to challenge long-held assumptions, and Pluto gives him plenty to talk about. Unlike the near-circular, flat paths traced by most planets, Pluto's orbit around the Sun is dramatically tilted and stretched. The solar system's planets largely orbit within the same thin, disc-shaped region known as the ecliptic plane. Pluto, however, ignores that neat arrangement. Its orbit is inclined by about 17 degrees relative to this plane. That's enough to make it swing far above and far below the main planetary highway as it makes its long journey around the Sun. But Pluto's orbit is also highly eccentric, and this means that it's not a perfect circle, but more like a stretched oval. At its closest point to the Sun, called perihelion, Pluto is about 30 astronomical units away, with 1 astronomical unit being the average distance between Earth and the Sun. At its farthest point, called aphelion, Pluto is about 49 astronomical units away. This difference in distance is huge, and it means Pluto's surface experiences extreme variations in sunlight and temperature over the course of its orbit. Because of this unusual shape and tilt, Pluto's path sometimes takes it closer to the Sun than Neptune. In fact, from 1979 until 1999, Pluto was actually inside Neptune's orbit. This situation is especially alarming when you imagine 2 planetary bodies on a collision course. But there's more to the story than you could imagine. Another unusual feature of Pluto is its rotation. It spins in the same direction as most planets, but it takes a surprisingly long time, about 6.4 Earth days, to complete one spin. In other words, a single Pluto day is longer than a week here on Earth, and its year is truly vast. Pluto needs 248 Earth years to make one trip around the Sun. That means no human has ever lived through a full Pluto year. Since its discovery in 1930, Pluto hasn't even made it halfway through its current orbit. It is these extreme and awkward characteristics that led Tyson to famously call Pluto a gravitational misfit in our solar system. It doesn't conform to the tidy patterns we see in the 8 main planets. Its tilted, elongated path, its sometimes Neptune-crossing position, and its slow spin all mark it as an outlier and a world that challenges our sense of order in the solar system. But the real question is, Were Pluto and Neptune always destined to collide into each other? And what could be the reason behind this universe-changing event? The answer lies in a precise orbital relationship that acts like a cosmic safety mechanism, revealing just how intricate and well-ordered our solar system can be. The orbital resonance that prevents collision. At first glance, the fact that Pluto's orbit crosses inside Neptune's might sound like an astronomical disaster waiting to happen. With two massive bodies and one path, it's easy to picture a slow-motion collision unfolding over millions of miles. But the truth is far stranger and far more elegant than that. Pluto and Neptune are locked in what astronomers call a 3-to-2 mean motion resonance. That's a technical way of saying that their dance around the Sun is perfectly timed. For every 3 trips Neptune makes, Pluto makes exactly 2. This rhythm means the two worlds are never in the same place at the same time, no matter how their paths appear to cross when viewed from above. But this isn't just about orbital timing. There's another safeguard built into the system, something called libration. Instead of tracing a perfectly repeating loop, Pluto's orbit actually wobbles, or oscillates, around a safe zone relative to Neptune's position. This gentle swaying motion makes sure Pluto never drifts too close. Even at its closest approach to Neptune's orbit, it stays millions of kilometers away. Add to this another subtle mechanism called nodal precession, and the system becomes even more secure. The points where Pluto's orbit crosses the plane of the solar system slowly shift over time. This gradual drift means that even if their paths look like they cross, those intersection points are constantly moving, further reducing the chance of any close encounter. And here's where it gets even more fascinating. Neptune's gravity isn't just a passive player in all this. It actively fine-tunes Pluto's path, pulling ever so slightly in ways that help keep this cosmic choreography stable. The result is a self-correcting orbital relationship that's been in place for billions of years. Long-term computer simulations confirm it. This isn't a fragile arrangement that might fall apart next week. Models stretching billions of years into the future show the resonance holding firm. Pluto and Neptune have been playing this gravitational duet for longer than life has existed on Earth, and they just might keep at it long after our planet is gone. But what happens when something disturbs that harmony? Because while this resonance has survived for billions of years, the solar system is not a static place. It changes, it evolves, and under the right or wrong conditions, even a dance this perfect could stumble. Disruptions that could break the stability. One of the biggest threats comes from something we can't easily predict: passing rogue planets. Astronomers believe there may be planet-sized objects wandering through our galaxy, not bound to any star. They drift silently, dark and cold, for millions, sometimes billions, of years before crossing paths with other star systems. If a rogue planet passed close enough to our solar system, its gravity could nudge the orbits of Neptune or Pluto just enough to throw off the delicate timing of their resonance. And even a small shift in position or speed could cascade into larger and larger changes over time. Another possible destabilizer lies closer to home, and it's the shifts in Jupiter's orbit. Jupiter is by far the most massive planet in the solar system, and its gravitational influence reaches deep into the outer solar system. If something, such as a long-term gravitational interaction with Saturn, altered Jupiter's orbit even slightly, the ripple effect could extend outward, subtly reshaping the paths of Neptune and Pluto. And over millions of years, those small distortions could build into something more dangerous. Perhaps the force we rarely think about because it acts so slowly is galactic tides. Just as the moon's gravity raises tides on Earth, the collective gravitational pull of the Milky Way exerts a kind of slow-motion tidal effect on the farthest reaches of our solar system. This is especially true for distant objects like Pluto. Over tens of millions of years, galactic tides can shift or tilt the orbits of these outer worlds, introducing new instabilities into systems that once seemed perfectly balanced. So, what would happen if the resonance between Pluto and Neptune were to fail? The possibilities are unsettling. If their paths ever lined up for a real encounter, the two bodies could be drawn into a collision. The energy released from such an impact would be staggering and equivalent to billions of the most powerful nuclear bombs ever built. The aftermath would be violent and far-reaching. A collision would blast an enormous cloud of debris into the Kuiper belt, potentially altering the orbits of many nearby objects. Some fragments might even be hurled inward toward the planets we know best. And that leads to an even more dramatic possibility. Gravitational slingshot effects could send swarms of comets hurtling toward the inner solar system. While most would burn harmlessly in the sun or pass by unnoticed, a few could hit planets, including Earth, with catastrophic consequences. The difficulty is that in a three-body system like the Sun-Neptune-Pluto arrangement, predictions only remain reliable for so long. According to chaos theory, after about 10 to 20 million years, small uncertainties in position or speed grow so large that precise forecasting becomes impossible. In other words, we can model their orbits with great confidence in the near future, but stretch the clock far enough and the system becomes inherently unpredictable. Although the chances of a disruption are quite low, the forces capable of breaking it are real, and the timescales we're dealing with are vast. In cosmic terms, stability doesn't always mean forever, but to understand just how vulnerable Pluto might be to the hazards lurking in its region of space, you need to understand its home turf, the Kuiper belt. The Kuiper belt, Pluto's hazardous neighborhood. If Pluto seems unusual compared to the 8 main planets, that's because it's not really part of their world. Pluto's true home lies in a distant and far less orderly region called the Kuiper belt, a vast ring of icy objects beyond Neptune's orbit. This is not an empty wilderness. It's more like a crowded scrapyard at the edge of the solar system, littered with ancient fragments left over from its formation 4.5 billion years ago. The Kuiper belt begins just beyond Neptune, around 30 astronomical units from the Sun, and stretches outward to about 50 astronomical units. It contains countless frozen bodies, some no larger than a mountain, others rivaling Pluto in size. Among its residents are other dwarf planets like Eris, Haumea, and Makemake, each with their own strange shapes, unusual rotations, and peculiar orbits. Eris, in particular, is slightly more massive than Pluto, and played a key role in the debate that ultimately led to Pluto's reclassification as a dwarf planet in 2006. Pluto's own discovery in 1930 came decades before astronomers even knew the Kuiper belt existed. Back then, Pluto was seen as a solitary outpost in the deep freeze. But by the 1990s, improved telescopes revealed that it was just one of many icy worlds scattered across this region. Mapping the Kuiper belt has not only expanded our understanding of Pluto, but it has also shown that the solar system is far more complex and layered than we once imagined. But this complexity comes with danger. The Kuiper belt is dynamically unstable. Most of its objects follow long, looping orbits that can be altered by gravitational nudges from the giant planets, especially Neptune. Sometimes, these nudges can send smaller bodies inward, where they become short-period comets and icy travelers that sweep past Earth and the inner planets. There's also the tantalizing and slightly unsettling Planet 9 hypothesis. Some astronomers believe a massive, as-yet unseen planet, perhaps 10 times the mass of Earth, lurks far beyond Pluto, shepherding the orbits of certain Kuiper belt objects into strange alignments. While no one has directly observed Planet 9, the gravitational patterns it could explain are difficult to dismiss. If it exists, this mysterious giant would be influencing the Kuiper belt from the shadows, subtly shaping the fates of worlds like Pluto. Even worlds much closer than Planet 9 can exert influence here. Jupiter, for instance, has an indirect but powerful role. The largest planet in the solar system can't directly affect Pluto's orbit from such a great distance, but it does affect Neptune's. And because Neptune is Pluto's orbital partner, any long-term changes to Neptune's motion can ripple outward to Pluto's path. But Pluto's stable relationship with Neptune may itself be a relic of a much more chaotic era in solar system history. In their early days, the giant planets did not form in their current positions. Planetary migration, known as slow shifts in the orbits of Jupiter, Saturn, Uranus, and Neptune, reshaped the solar system's architecture over hundreds of millions of years. During this migration, Neptune likely moved outward, ploughing through the early Kuiper belt. As it did, it captured Pluto into its 3-to-2 resonance, locking it into the safe orbital rhythm we see today. Without that ancient gravitational handshake, Pluto might have been just another wandering body, vulnerable to collisions or ejection from the solar system entirely. But the real question is, if the Kuiper belt is this dynamic, and its objects can be nudged inward toward the Sun, what does that mean for the worlds closer in? Could a change out here, on Pluto's doorstep, ever ripple all the way toward us? Could the Earth be affected? When the International Astronomical Union made the controversial decision in August 2006 to officially reclassify Pluto as a dwarf planet, the backlash was strong. The reasoning came down to 3 criteria for planethood. A body must orbit the Sun, be massive enough for its gravity to pull it into a roughly spherical shape, and, here's the sticking point, it must clear its orbital neighborhood of other debris. Pluto failed that last test. Its path through the Kuiper belt is shared with countless other icy bodies, meaning it doesn't dominate its orbit in the way planets like Earth or Jupiter do. Neil deGrasse Tyson became one of the most visible advocates for Pluto's demotion. As director of the Hayden Planetarium, he had already quietly removed Pluto from the main planet display years earlier, grouping it instead with other icy Kuiper belt objects. When the reclassification became official, Tyson was suddenly in the crosshairs of public opinion. Some called him a science educator willing to speak hard truths, while others accused him of killing a planet beloved by generations. The backlash was enormous and sometimes funny. Memes exploded across the internet. Cartoons depicted Pluto as a sad, rejected world. Late-night talk shows joked about its firing. And Tyson himself reportedly received angry letters, many from schoolchildren who didn't want to lose their 9th planet. It was a rare moment when orbital mechanics and planetary definitions spilled over into mainstream culture. But then, in 2015, the National Aeronautics and Space Administration's New Horizons spacecraft made its historic flyby of Pluto, delivering the first close-up images of the distant world. What scientists saw shattered the notion of Pluto as a cold, dead ice ball. Vast nitrogen glaciers flowed slowly across its surface. Towering mountains made of solid water ice rose as high as the Rockies. A delicate blue haze hung in its thin atmosphere, scattering sunlight in colors eerily reminiscent of Earth's sky. Even more surprising was evidence suggesting a possible subsurface ocean hidden beneath layers of ice. If true, that means Pluto could have pockets of liquid water in the most unlikely of places, raising new questions about where habitable environments might exist in the solar system. And unlike many small worlds, Pluto is geologically active. Its surface shows signs of recent reshaping, meaning internal heat or other processes are still at work. These discoveries reignited public fascination, and people who mourned Pluto's demotion saw it as something even more mysterious and complex than they'd imagined. In a strange twist, the very science that had led to its reclassification also deepened its cultural legacy. But Pluto's story isn't just about classification debates or breathtaking landscapes. There's also a distant, indirect link to our own planet's safety. As part of the Kuiper belt, Pluto sits in a region that is gravitationally connected to the rest of the solar system. A disruption in that region, whether from a passing rogue planet, the pull of a hypothetical Planet 9, or even long-term shifts in the giant planet's orbits, could alter the paths of countless icy bodies. Some of those bodies could be nudged inward toward the Sun, and a few might intersect with Earth's orbit. History tells us that large impacts, while rare, can have devastating effects. The extinction of the dinosaurs 66 million years ago is the most famous example, and while that was caused by a rocky asteroid, a large enough comet could be just as destructive. Pluto itself poses no direct threat to Earth because it's far too small and too distant, but the stability of its orbital neighborhood helps keep the flow of incoming comets in check. If that balance were disturbed, the chain reaction could increase the odds of dangerous impacts over long timescales. It's a humbling reminder. Events at the outer edges of our solar system, far beyond the reach of sunlight's warmth, can eventually echo all the way to our own world. And while Pluto may no longer be called a planet, it remains an important piece of the solar system's architecture whose fate is tied, however loosely, to our own. Pluto remains a small world with a big presence, capable of stirring both wonder and debate. And thanks to voices like Neil deGrasse Tyson's and the continuing work of spacecraft and telescopes, it's a world we'll never look at quite the same way again. What do you think? If Pluto's fate can change in an instant, is the Earth safe? Drop your answers in the comments section below. If you enjoyed this video, don't forget to click on the next video on your screen, like this video, and subscribe to our channel for more updates.